You might have a need to analyze circuits, design circuit components, or calculate unknown values of voltage, current, or resistances. Ohm's law is a fundamental basic principle in circuit theory that helps with circuit analysis. Ohm's law states that the voltage or potential difference between 2 points of a conductor is directly proportional to the current or electricity passing through the resistance. Okay, so we have V directly proportional to I. If we introduce the constant of proportionality R, we would have V equal to IR. To easily remember this formula, we could have a triangle like this. We can deduce that V is equal to IR. We have I equal to V over R, and we have R equal to V over I. So what this implies is, if we have a circuit like this, and we have our voltage to be 9 volts and the resistance of 1 mega ohm, to find our current, we would have to apply the formula I equal to V over R, which is equal to 9 volts over 1 mega ohm. And that would give us 9 times 10 raised to the power minus 6 amps, which is same as 9 microamps. So let's hold that there and let's talk about electrical work done in a circuit. Work is done in a circuit when Q coulombs of electricity flows between 2 points with potential difference of V volts. Its unit is joules. So work is equal to charge times voltage, where our charge is equal to I times T, which is current times time. We can also say from Q that work is equal to IVT or I square RT. Of course, we know that V equals IR. If we take away V and bring in IR, we'll have I squared R. Okay, so that's how we have that formula. Also, power is the rate at which work is done, and power is equal to work over time, which is also equal to IV or I square R, where I is current, R is resistance, V is voltage. So back to our circuit. Knowing the power rating of your resistor is very important. If you exceed this power rating, you will damage your resistor. Okay, so in this case, of course, we remember our voltage is 9 volts, our resistance is 1 mega ohm, and our current through this place has been found as 9 microamps. Okay, so what is the power of this circuit? The power is current times volts, which is 9 microamps times 9 volts, which gives us 81 times 10 raised to the power minus 6 watts, which is 81 microwatts. So we can see that the wattage of the resistor has to be at least 81 microwatts if the resistor has to withstand the amount of current flowing through it. Otherwise, the resistor is going to get burnt. Okay, let's do something here quickly. Okay, so we have this resistor, which is a red, black, and gold resistor. So that would be 220 ohms. So we have a 220 ohms resistor, and we have a battery, a voltage source of 9.6 volts. If we put this together as a circuit, how much current is going to flow through this configuration? So we have I equal to V over R, which is 9.6 volts divided by 220 ohms. So this is going to give us 0.0436, which is approximately 43.6 milliamps. All right, if that is the case, how much power would be dissipated by our resistor? We have power equal to IV. So if this current is going through the resistor and we have this voltage across that resistor, it means we're going to have 43.6 milliamps times 9.6 volts, which would give us 0.419 watts. Okay, so if we look at this critically, we know that the resistor is going to dissipate this much power. We have to use a resistor that can withstand this power, and we know that the 1/6 resistor can't, because it can withstand a power of 0.1667. 1/4 is 0.25. So we have from 1/2 watts resistors, we can use that. So because that's 0.5 is bigger than this, but then we're going to use, our resistor is about 1 watt, so I mean we're safe, all right, because it can withstand 1 watt, and we're about to make it dissipate 0.419 watts. Okay, so It's a simple circuit. We have a 9.6 volts battery. Okay, we can confirm that. So we have a 9.66 volts battery. Okay, so we use our multimeter as an ammeter now. Alright, so this is our resistor. Let's connect it to the red wire, the positive of the battery. Okay, so look at the meter closely. We want to confirm what we have as the current flowing through the circuit. Alright, so we can see we have 43 milliamps flowing through the circuit. Okay, and from our calculations we have 43.6 milliamps. So you see, this is the amount of current flowing through the circuit, flowing through the battery into the resistor, through the ammeter and back into the battery. Okay, so that was a simple circuit. Okay, we have the battery source or the voltage source, which was 9 volts. We have the resistor and we had an ammeter. So the ammeter was placed in the circuit so that we could get the reading of the current flowing through it, but it's just a very basic circuit like this.